All right, hello everyone. Welcome to DV Systems webinar series. We're excited to introduce our second webinar on the B series Huron B10 Rotary Screw Air Compressor. My name is Bogusz Szurkowski. I'm the marketing manager here at DV Systems, and I will also be accompanied by Luke Thrush, our design engineer.
Hello everyone, thanks for joining us.
So let's proceed and discuss our agenda for this webinar. We will commence with an overview of features, then we will discuss an internal component overview. This will be followed by a video walk-around of the B10's key features, after which we will discuss the B10 Huron's value proposition and conclude with a Q&A session where we will take audience questions. So the B series B10 rotary screw air compressor, it's a 10 horsepower air compressor. It delivers 37 SCFM of air, and it does this quite quietly, clocking in at 68 decibels. Its first unique feature is its revolutionary single-phase 10 horsepower design. This allows installation in locations where it was previously uneconomical or impossible. It also features the energy-saving variable speed direct drive technology. This comes with a NEMA 4 enclosure. It also features the CC300 Advanced LCD Microprocessor Control solution. It features the integrated air aftercooler, which effectively cools air and enhances system efficiency. It features a solid and silent, rugged construction and quiet operation design. The B10 is easily serviceable with innovative component integration. And like all of our rotary screw air compressors, it features a 5-year extended warranty. All you have to do is register the product online within 30 days of purchase, maintain it properly according to the service manual, and use only official DV Systems parts and kits. So the B10 Huron Rotary Screw Air Compressor uniquely features a revolutionary single-phase 10 HP design, unprecedented in the marketplace. This allows for installation in locations where it was previously uneconomical or impossible, and is ideal for remote locations or areas where three-phase power is unavailable or costly to connect. And it features a maximum 55 amp draw on a 230 volt, 60 hertz single-phase configuration. Take note that three-phase voltages are also available for this model. So the B series B10 Huron comes in two configurations, tank mounted and air system. The tank mounted configuration includes an 80-gallon air receiver, and the air system configuration includes an 80-gallon air receiver, an ASD40 air dryer, along with a 3-micron pre-filter. So let's talk a little bit about the uniqueness of the air system configuration, and specifically it employs what we like to call the dry tank design. So what is the dry tank design? It's a unique compressed air system configuration developed by DV Systems. It delivers clean, dry, compressed air directly to the air receiver by employing the combination of a filter and dryer. This configuration ensures that the tank is virtually dry, preventing the buildup of corrosion in the tank and maximizing the capacity of the tank for its intended use, to store and provide continuously cool, clean, dry air for your required applications. So to the right here, you can see that the air leaves the air compressor via an air aftercooler, which contributes to the discharge of air temperatures as low as 15 degrees above ambient, reducing energy consumed by air dryers and promoting system efficiency. So the compressed air leaves the air compressor, it enters the 3-micron pre-filter here, and then the clean air leaves the pre-filter and goes directly into the dryer, where it is cooled and enters the tank, and it is cool, clean, dry air entering that tank, and that's what we call the dry tank design. So let's talk about the CC300 controller, as it's integral to the variable speed drive option in the B series B10 Huron rotary screw air compressor. The CC300 controller is an advanced LCD control solution. It effectively manages, monitors, and maintains optimal operational parameters to ensure stable system pressure and reliable operation. Some of the features of the CC300 controller are its remote stop-start operation, a real-time clock with an advanced run schedule, sequencing control of up to 8 compressors, web-enabled system control, a current or amperage draw display, remote fault signals and power failure restart capabilities, a service maintenance reminder, and advanced motor and phase protection. Let's discuss the B10's variable speed drive technology. The variable speed drive technology increases energy savings by aligning energy use with air demand. How does it do this? It eliminates inrush current spikes on startup, so the motor is gradually increased on startup. It eliminates artificial demand. The VSD's pressure tracking controls ensure energy use is optimized by producing only as much air as is needed at set pressure. And this is ideal for varying demand scenarios. So it delivers maximum operating flexibility with efficient full and part load performance. The VSD also integrates numerous power monitoring and fault protection technologies, making it extremely safe. Let's go on to discuss the B10's one-to-one direct drive technology. This further enables efficient power transmission and optimizes power consumption for the unit. The direct drive is a self-aligning drive that connects the motor directly to the high-efficiency air end with a low-maintenance coupling, and it provides maximum transmission efficiency and durability in use. Now Luke Thrush will discuss the internal components of the B-Series B10 Huron.
Okay, so this is a view from the back of the compressor. The first option here is the air oil separator filter. Point 2 is the pressure transducer, which is located here. Behind the pressure transducer is the minimum pressure valve. And then here we have the safety valve. Number 5 is the solenoid, which controls the intake valve. Number 6 is the scavenge line, which brings oil back into the air end from the air oil separator filter. Number 7 is the temperature sensor. Here is the motor air end coupling housing, and this is the premium efficiency motor that you can see here. This is the heat exchanger, and number 11 is the integrated cooling fan and housing. And also on the B10 we are employing the steel tube design, as you can see here. Okay, moving on. This is a view from the front of the unit. So once the service panel is removed, you have easy access to the air filter located here. You can remove this plastic covering and have access to the filter. Once again, we have the heat exchanger and the motor air end coupling here. Number 4 is the oil cap, and you see here the oil valve and discharge tube. And we also, the air end and motor are both mounted on isolators located at the bottom here. This is the oil filter, so it's easily accessible to replace. And again, you see the steel tube design. Moving to the outside rear of the unit, you see the back of the air dryer and the 3-micron pre-filter here. The dryer has a nameplate where you can find dryer technical information and the serial number of the dryer. For again, the steel tubing, as you can see here. And this is our easily connected electrical enclosure.
So now we move on to a video walk around.
Okay, so once you've removed the front panel, you can see here this is the CC300, and you have the control panel box as well. The variable speed drive is located right here, controlling the speed of the motor. Inside you have the air filter. This is accessible by removing the nut on top of the filter housing, and then once the nut is removed, you can lift the plastic casing off and have access to the filter. So that's easily accessible once the front panel is removed. And then again, just simply put back the nut on top to seal the housing. Okay, in the front here we have the oil fill port. Just spin off the cap and then the valve for the oil drain, and the oil drain tube simply comes out the front for easy draining of the oil. We have the oil filter in the front as well, and behind the air filter is the air oil separator filter, all easily accessible from the front. And this is the air end and motor coupling, which is easily accessible. So moving to the back, we have the integrated fan housing. This cools the unit. We have the premium efficiency motor, which is connected to the air end by the coupling. And we have the solenoid and the air oil separator filter on top here, minimum pressure valve, and the pressure transducer. We have the solenoid beneath that, and the temperature sensor. As you can see here, this is a scavenge line, and then the safety valve on the top of the air end. Here we have the heat exchanger, which brings air out of the unit through the 3-micron pre-filter into the dryer and back down into the tank. We also see the electrical enclosure. You can simply remove the cap and then have access to your electrical connections there. The dryer has a nameplate on the back of the unit, the serial number and information, and the nameplate of the unit is also located on the side panel there.
All right, thank you, Luke, for that walk around. So let's review some of the key features of the B Series B10 Huron. It's got a revolutionary single phase 10 HP design featuring a maximum 55 amp draw. It has a variable speed direct drive technology featuring a nemiform closure, which is dust and moisture proof. It features the CC300 Advanced Control solution. Also features a premium efficiency industrial TEFC motor. The B10 also features an air after cooler, an integrated cooling fan. It has increased ruggedness with its new steel tubes. It has an integrated air end and oil reservoir, and angled front panel improves visibility. So let's talk a little bit about the B10 Huron's main value proposition, its energy efficiency, specifically relating to its variable speed direct drive technology. The initial fixed cost of a rotary screw air compressor is only a fraction of its total life cycle or operating cost. The greatest proportion of costs incurred in the operation of a compressed air system are its energy costs. Variable speed drives present a considerable opportunity to reduce the cumulative energy costs of your compressed air system by as much as 24%. So, how do variable speed drives do this? VSDs align energy use with air demand and produce only as much air as is needed at set pressure. VSDs draw power in direct proportion to the load, with energy consumption approximating 0% at no load versus 13 to 85% at full load consumption. Secondly, VSDs eliminate inrush current spikes on startup. The motor speed is gradually increased on startup, eliminating inrush current spikes and contributing to the compressed air system's overall energy efficient operation. Thirdly, variable speed drives eliminate artificial demand by reducing system pressure. Each 2 psi reduction in system pressure equals a 1% reduction in energy consumption. VSDs are typically set 20% lower in psi than traditional load-no-load air compressors. All these factors contribute to considerable energy savings. So moving on. Let's talk about variable speed versus full voltage start drives, specifically as it relates to their starting current and energy consumption. The gray line on the graph to the right signifies a full voltage start air compressor, and you can see at the very beginning of its operation that an inrush current spike on startup is evidenced. This inrush current is typically 7 times the proportion of the current displayed on the nameplate. Comparatively, the orange line signifies the startup current profile of a variable speed drive air compressor. And you can see that the variable speed drive starts the motor with a gradual speed increase, eliminating any inrush current spikes on startup and consequently reducing your electricity costs. Let's move on to talk about artificial demand. So what is artificial demand? Typically, it's when an air system is overpressurized and you are producing more air at a higher pressure than you actually need to service the demands needs of your shop or application. So remember, variable speed drives only produce as much air as is needed at set pressure and maintain operating pressure within 1 psi. This allows pressure to be typically set 20% lower versus load-no-load driven compressed air systems. Each 2 psi of pressure reduction equals a 1% increase in energy savings. The graph to the right compares the pressure profile between a traditional load-no-load air compressor and a variable speed drive air compressor. The wavy or sinusoidal black line represents the pressure profile of a load-no-load air compressor over time, and the straight orange line moving across at 135 psi represents the pressure profile of a variable speed drive air compressor over time. You can see that the load-no-load drive cuts in at 125 psi and cuts out at 145 psi, and the variable speed drive air compressor maintains a set pressure of 135 psi over time. So, the orange shaded areas signify your potential energy savings. These areas represent the overpressurization in the system, or in other words, the artificial demand. So remember, variable speed drives maintain operating pressure within 1 psi and typically allow pressure to be set 20% lower than traditional load-no-load compressed air systems. If 2 psi of pressure reduction equals a 1% increase in energy savings, eliminating 20% in overpressurization results in a 10% increase in energy savings. That's considerable savings right there. Let's discuss the available models and voltages of the B-Series rotary screw air compressor. It comes in both single-phase and three-phase options, and it comes in both its configurations in these options, meaning the air system with a tank and dryer and just the tank options. Moving on. Let's recap some of our key features of the B-Series B10 Huron. It has a revolutionary single-phase 10 HP design. It's got a variable speed direct drive with a NEMA 4 enclosure. It features an advanced CC300 Control solution, improved ruggedness and reliability due to the steel tubes, etc. It features powerful delivery at 37 SCFM, and it does this extremely quietly at 68 decibels. And it also features an 80-gallon air receiver tank. So let's now move on to our Q&A session where we will field questions from the